All right, welcome back to a new episode of the Lobster Talks podcast by Lobster Capital. I'm very happy to bring back this series where I interview successful YC founders so you can learn from them. And today, to kick us off on this new format or on bringing this format back, I'm very excited to have Valentin here with us, the founder of Ionworks. Valentin, thank you so much for being here.
Yeah, Gabriel, thank you so much for having me. Yeah, great to be with you.
Awesome. Exciting. So let's dive in. You're the founder of Ionworks. Ionworks is the latest, newest solution to create from scratch a new battery, a new format. Batteries are not everywhere, and you're doing this in software instead of a lab. Tell us a little bit of what you guys do, and I'm very excited about it. Let's see what you do so everyone can understand.
Yeah, we're building in the space of batteries because we think it's one of the crucial technologies of the 21st, going to be as important as oil was in the 20th century. If you think about everything we need to do to fight climate change, get electric vehicles, get renewable energy, all of that is really bottlenecked by having better batteries that enable us to develop all those other technologies and transition to green electricity. And then what Ionworks is doing is really supporting companies through software in order to enable those new and advanced batteries. So we're helping companies do things like increase how quickly they can charge their batteries or develop batteries that have much longer range. So your electric vehicle can now do 500 miles of range. Also unlocking new applications like electric airplanes, satellites, completely green energy, all kinds of things that are not possible today that are going to be really possible in the future as we develop better and better batteries. And Ionworks is here to support that movement forward of that ecosystem.
That's awesome. Very exciting. Let's dive in. Batteries are everywhere, not just in our cars. They're in almost everything we do in our smartphones and computers. And now they're even in satellites. Maybe we get to talk about this. And so just to help everyone understand, if I'm not mistaken, the previous solution, the previous way before what you're doing, before Ionworks, to create a new battery and test its capacities, maybe have a new form factor, charging it faster, like you said, or having it last longer. The previous solution was to just sort of build it and test it and do it physically in a lab. And you're allowing companies to do this on their computer. Is that correct?
Yeah, that's exactly right. Yeah. Today, even if you want to develop a new battery, the companies that have been doing this over the last 10 years, they've spent 10 years and $1 billion to get that new technology to the market. The reason it's so expensive is because had to do so much physical experimentation. And these experiments are insanely expensive, $1,000 for a single battery experiment. Where we come in is we've really developed physics-based, accurate models of the batteries. So now instead of having to do those experiments in the physical world, you can do them in the virtual world instead. And it's much easier to explore that wide design space and find the perfect design that's going to meet all your needs in the virtual world than it is in the physical world. Now, obviously, we're not completely replacing experiments. You still have to do a little bit of testing at the start to calibrate the model, and then at the end to validate the findings of the model and make sure that what the model is telling you is really the same as reality. But for that middle 90%, we're really helping to cut that down by using models to search the space instead of the physical experiments. And to go on a bit more about that, it's an approach that is new-ish for batteries, but it's really been applied to lots of other fields very successfully. So if you think back to the 1980s, the way that people used to design airplanes was making a physical prototype, maybe smaller scale, but still an actual physical prototype of the airplane, putting it in a wind tunnel, and then testing it and checking, like putting lots of measurements over the wings, seeing what the lift, the drag, everything was. That's now been completely shifted over to something called CFD, computational fluid dynamics. And now the way that the top airplane companies, the top F1 companies all do that airline design is first in the computer. And then at the end, they put the best designs in the wind tunnel for that kind of final validation and testing. But the bulk of the design happens in the computer. And really, there's nothing that fundamentally different about batteries compared to those other fields. So that means that we shouldn't be able to do the same thing for batteries. And that's the future we're trying to enable with Ionworks.
That's absolutely awesome. It sounds so obvious when you're thinking of the plane. You don't build a replica. You used to, but you don't anymore build a replica plane. But still in 2024, most companies, before they're working with you, they're still building model batteries in their labs in order to use the computerized version. And also I wanted to add is that what computers and software are really good at is running hundreds of thousands of different versions and instances at the same time to optimize and find the best result. You don't actually care the input. You can put random inputs, whatever you want, whatever shape and form of plane, it will end up optimizing itself to find one of the perfect, best aerodynamic shape for the plane. And so one of the best format factor for the fatter battery itself. And so that's another extremely important and good reason to bring this inside the computer. Just makes everyone's life much easier. And so batteries are sort of a big deal. I think the first time we met, you told me that batteries are going to be, 3-4% of global GDP by 2030. That's the numbers I remember. I don't know if they're correct, but it is a big deal, correct?
Yeah, basically, if you think about the size of the transportation industry today, the $9 trillion industry today, and roughly in an electric vehicle, the cost of the battery is between a third and half of the total cost of the electric vehicle. So if today we tried to make in transportation electric, we would need $4-5 billion worth of batteries just to electrify all transportation that exists. Obviously, there's going to be some cost savings. It's going to come down. It's not wild to think that based on the size of the sectors that batteries are going to unlock, there's going to be these huge economies that batteries open up. And that's without even thinking about all of the new technology that's not even close to being electrified today that we're going to be able to electrify as we make batteries that are 3-4 times the capacity and the performance of what we have right now.
Give us examples, please.
So the big one, the big holy grail for batteries is aviation. And then within aviation, there's different ranges. There's your New York to, here's my example, San Francisco to LA, kind of short distance. New York would be like JFK to Manhattan. That's a distance, the kind of helicopter distance, like ultra short range. So the ultra short is being electrified today with those electric vertical and takeoff eVTOL applications that have been developed. The kind of SF to LA distance, kind of short haul, is probably within reach. Then you have New York to London, long haul. Not sure if within the laws of physics, batteries are going to enable that really. It might be other things like biofuels or fuel cells. But the kinds of things we're thinking about is unlocking those different applications. And the better batteries get, the wider that envelope gets of potential. And there's some cases where it's maybe not even possible to think of it because it's going to be down to that next generation of entrepreneurs in 20 years' time when batteries are so cheap and so performant to think, oh, well, why couldn't we do this in space travel and things like that? I think as technology develops, we always had these surprises that seem like they were never going to be possible. Become possible. And I think batteries is really one of those technologies that is going to create some of those unlocks in the future.
It really is interesting because if someone, you're right, like the New York to London electric plane is a holy grail. And you said, I'm not sure if the laws of physics will allow this to ever happen, but shouldn't one company, if someone has the answer, it should be you. I don't know if you can just put this into your model, maybe not, I guess, otherwise you would tell me the answer already, but is there a way for you to say, hey, I want something that's able to fly, it has enough energy to fly itself, but can still have whatever 6-7 hours of lifetime? And so is it a scientific constraint because you have the mass compared to the energy to fly yourself, right? But you should be the one to make it happen with your software,
okay,
right?
So actually, there has been some research done on this by Professor Venkat Viswanathan, who's actually one of the advisors for Ionworks.
Oh,
and,
amazing.
Also Alec Bims, who's now one of the employees at Ionworks.
Wow.
And Shashank Sripad, who is working in the company, who started the company that does batteries for eVTOL. And basically their research shows as you get to different levels of battery performance, what applications are unlocked. And New York to London is basically too far. There's no battery chemistry on the roadmap that would get us there. But something short haul, there are chemistries that maybe would be possible, but there's so many things that we need to improve about those chemistries, improving the stability so they don't degrade so quickly. So there are chemistry, to give you an example, there are chemistries out there that you can discharge them once and they give you that much power, but the trick is them so you can use them again to bring the kind of cost feasibility, because there's no use having a plane that you can only use a single time.
Maybe for Elon Musk, it's a single-use plane.
Yeah, like this how rockets used to be, right? Yeah. those are the kinds of questions like, what are the chemistries, the battery chemistries that are way out there that have all these problems so far? But if we could solve all those problems, what would they enable? Really, I think that the limit for batteries is that kind of short range flight today. But you never know. There's so many different combinations of molecules that exist. I don't remember the exact number, but it's something like to the 10 or to the power of 10 combinations of possible molecules. We haven't explored all of them. There might be something out there that enables something even further along.
Let's wait and see. We should have AGI in only a few years. And so
Yeah.
AGI would probably try all of the possible combinations and just tell us the answer. But okay, you're not only trying to fly planes, though. If I'm not mistaken, you have customers just doing regular electric cars or regular smartphones or laptops, and also, I believe, a satellite company. So it is interesting that the applications are very, very broad. Where do you see the most pull from the market today? But also, where do you want to go? Like, you seem to be pretty interested in airplanes and flying. What are maybe some of the applications that we don't even think about for batteries that you already see customers are trying to pull off with your tool?
Yeah, to answer the first question, the main application for our technology today is for the kind of design aspect of the process. That can mean several things. It can mean if you're a company that's making a battery, trying to find the design that is going to best fit the needs of the market. So, for example, for the EV market, it's having low cost, long range, and fast charge. But for the consumer electronics market, for example, it's having cost and really lightweight. Your phone isn't too heavy in your pocket.
Well, the same.
Different markets have different applications. Satellites, for example, don't care about cost at all because the battery is only a tiny proportion of the cost to launch a new satellite. So it's really, for satellites, it's really all about the performance and getting the performance and the life of the battery as good as possible. But yeah, going back to the applications, it's really the design phase, and it's for companies who are buying the batteries. If you're an EV company, it's really understanding what the battery can do so that you can design your electric car around that performance envelope of the battery to really make the most of the battery that's out there. And to give you another specific design example, we're working with a company doing consumer devices. And for them, they have very specific constraints on the amount of space available for the battery within the product. And they really want to know if they change the battery in different ways to fit within the product, what's going to be the effect on performance, on power, energy, all those kinds of things. And obviously they could build a bunch of batteries and test each one, but that would mean that it would take them 10 years to the product to market. So instead they do simulations to do that much more quickly.
Very cool. It just allows everyone to just iterate so much faster. It's an obvious business model. It's not an obvious company that you built, but no one built it before. And I think it's a reason that you built it with your co-founders, because you guys are some of the leading researchers on batteries, correct?
Yeah, that's right. Yeah. We've both been in this space since 2016, 8 years working on battery simulations. I don't think we've definitely not people who've been working on batteries for the longest, but really being at that intersection of the batteries and the software is what makes our team and our company really unique, is that a lot of the battery world is very much in that kind of physical world orientation. We're the team that's most advanced on the kind of software side with the domain expertise of how batteries work. And that kind of combination is what is us to build the best battery simulation software that's out there.
It's incredible. I'm listening to you and I'm thinking it's a huge market, okay? Batteries are everywhere. And it's mostly a hardware world, but you guys are really like among the best experts. And in the software part, in the very small, I would say software, so far at least, software part of that huge hardware market. And I was listening to you, I was thinking to myself, man, this is such a perfect company for YC. That's not surprising at all that you guys were accepted there and went through YC, because again, they like scalable businesses with this very strong team on a very big market. And it's check. You're really absolutely perfect for that. It's no wonder. So you went through YC in 2024, actually, right?
Yeah, in summer 2024. Yeah, so we were over there in the Bay Area for the 3 months.
That's awesome. What was the experience for you? What was it like?
the biggest thing about YC is the people you meet. And that's both the partners, the group partners, and the alumni they invite back to give the talks who have been there and done it and been further along. But more importantly, the rest of the community who's in exactly the same situation as you. And you're seeing that the problems you're trying to solve are really not unique in terms of all of the problems that happen when you're trying to build a company and build it quickly. So having that kind of community of people to talk to compare experience with, both during YC and even in the 3 months since YC, just been the best part. And it's not just any people, it's the smartest, most ambitious people in the world who are trying to build companies, trying to do it fast, trying to get to that scale. It's incredible to have that kind of resource to lean on. Yeah.
Amazing. Incredible. Yeah. Congrats on going through YC. And it is a recurring theme that you hear. It's the people you meet. And people tell me also often it's the sort of peer pressure that everyone's just building maniacs working eight days a week and 36 hours a day. And that peer pressure applies on you as well to just go out and build. Okay, that's amazing.
The one thing that's super interesting is being in that kind of, in those two worlds, in the battery world and in the YC world. And they are different worlds in terms of, mainly I'm thinking in terms of the software side and like the knowledge of what's coming from AI. I feel like we're lucky from the battery side to see so much of what other companies are doing with AI, what they're bringing in and what's really possible to do now. And I think with the battery world, a lot of hard scientists is often a bit either reluctant or not aware of all the advances that are really lets us see 3 years before anyone else and make the most of that.
It is
in our product building.
It is true. I think it's another advantage of YC. You're absolutely right. I'm pretty convinced now that YC is one of the best places in the world to invest in AI, just because there's a number of factors. YC itself, they're very interested in investing in AI. 80% of the batches now are AI related or AI companies. Also, they're very close with Sam Altman and OpenAI, because obviously Sam was our CEO of YC before starting OpenAI. And so there's even been a hackathon. I think it was during your batch in summer 24, a special hackathon with YC and OpenAI. And YC companies have access to some of the latest models, some that are not even released to the public yet. And the last reason why I think it is one of the best places to invest in AI is also YC is attracting the most talented, the most talented entrepreneurs, investors as well, hopefully, but entrepreneurs to just come here and build. And so you have the most talented people in the world because it's the best incubator. So they're just drawn to it with one of the closest link to the biggest AI company in the world. And YC themselves are very much involved and heavily lying on AI. So all of those together makes for a very great place to invest in. I see many investors, colleagues who say, oh, I'm doing only AI, but I don't do YC for some reason. There's some people who don't like YC that. Maybe it's jealousy or something. But I'm thinking to myself, man, you're really missing out if you're in AI and you're not doing YC. It's also a great vantage point for you to see your batchmates and future batches, and for me as an investor there, to just really see what's going on with AI, with YC, and almost before it happens anywhere else. So it's good for you as well.
Like one very kind of inconsequential but specific example is coming into YC, my coding environment was code with GitHub Copilot. And that was pretty good. So
I thought you were going to say like something horrible. It's not too bad to get started. Yeah.
Then there was an informal hands-up survey that they asked about who's using, what were people using, what are the models, and everyone basically was using Claude with Cursor, or 60% were using Claude with Cursor. Yes. And so now we use Claude with Cursor, and it's absolutely incredible, and we're another 2x as fast compared to GitHub Copilot. And most people it's going to be years before they switch over to Cursor. It's just like getting the really state-of-the-art knowledge of what actually works and what you should use. Then there's more advanced examples with prompting techniques and all of the voice companies. We're not really doing voice, but those kinds of things, great to have that kind of informal knowledge that's not written down anywhere, but that the community has and you can easily tap into if you just pay attention to it.
It's true. I see this all the time. I often cite the examples of Supabase and PostHog, which both are YC companies. It's even funnier because it's like almost internal. And then almost everyone now in YC is using Supabase and PostHog. And like you said, if you go to a random company outside of YC, it might be 5 or 10 years before they switch. And so it just gives everyone an edge, an advantage. And what you talked about on using Copilot versus Cursor and Claude, that's exactly the same example. And I love that. So you have an edge on YC. That's absolutely brilliant. I wanted to talk a little bit while we still have time on the open source world, because we both haven't mentioned that, but I know for a fact that before building Ionworks, you were building something somehow similar, not the same, as an open source project. And it's not exactly, correct me if I'm wrong, but it's not that you transition exactly the same project with the same people from open source to for profit. Is you're building another company on top of the open source thing that still exists and has a life of its own. Am I correct here?
Yeah, exactly. Yeah. So I'll start with a bit about the open source project, which is PyBAM. That is something that my co-founder Rob and I and a few other people started in 2018 when we were still researchers at the University of Oxford. And my main motivation when we're starting that project was there was a lot of talk at the time about the scientific reproducibility crisis and how results both in software and in experiments that some researchers were publishing were not possible to reproduce from others. And I thought, I don't want to contribute to that. So that open source project to kind of show that my research was real and that other people, if they wanted to check it, all they had to do was go to this open source and just download it, and they could see for themselves that I wasn't making things up, basically, or I wasn't doctoring the results or things like that. That, and then the second motivation was a lot of people doing battery research at the time, or we were each in a kind of small silo, in a wheel on lots of different things. And it meant that the improvement that somebody was coming up with over here was completely not compatible with the other improvements somebody was coming up with over here, because there were no way of combining them together. And so the big motivation of PyBAM, or as some people have called it, the common modeling framework, is to really make it easy to combine all of the improvements that people are making, so that instead of being one-offs, they really build on top of each other. And then you get compounding effect of having much faster numerical solvers with much more accurate models, with much better parameters. All of those things really much stronger when summed up together in a single place, compared to individual researchers just doing it for the sake of publishing a paper, and then it sits there and it never gets used again because nobody knows how to pick it up and actually use it. And then the second part is how PyBAM became Ionworks, or how Ionworks grew out of PyBAM. And basically many open source projects like PyBAM are just completely dying once the main person who's pushing it moves out of their current job, their current PhD or postdoc, and goes and starts a job in industry. We really saw that there was a massive opportunity with PyBAM, with people from all kinds of places, all kinds of really great companies adopting it, and we didn't want to just let it die. And we saw that there was an opportunity to push way beyond what we were doing to academic scale and really make this like a professional, fast-growing software company that was serving industry as well as it could. And there's just no way to serve industry as an academic project. We have to create the company to do that. And so that was the big motivation for starting Ionworks. We've got a good start with PyBAM, but we can really go much faster and go much further by starting the company. And that's what we've done.
That's awesome. Thank God. What was I don't know, were some people not happy in the open source project that you were starting something else? What was the relationship? What was the transition? Has there been some friction? Some that you can talk about, maybe some of it is confidential. Was everything just peachy and everyone was happy? I'm guessing there might be some unhappy people. We saw what happened with OpenAI transitioning from non-profit to for-profit, even though that was the same company. So it's not the same situation. Whatever you can talk about, how did you go about those discussions and potential risks or conflicts of interest? I don't know. Just want to try to understand how it went down.
Yeah, I think there's been a decision on the side of keeping the community happy, maybe sometimes even to the detriment of Ionworks. So the big first decision we had to make was, is PyBAM a project that is by the community, jointly the shareholders are from the community, or is it Ionworks and Ionworks decides what happens to PyBAM and nobody else gets to say? And we decided to go for the first option and donate all of the code from PyBAM to the community. So now it's a community managed project with a steering committee that I'm on, but the rest of the steering committee is not from Ionworks.
Impressive. Yes.
And so that has helped the transition to be very smooth, because people see that, okay, PyBAM is this one thing and Ionworks is this other thing, and they do different things. And the very clear separation that we've made is essentially PyBAM is for the science. So all of the next generation models and things like that of PyBAM. And then Ionworks is for the engineering. So taking the science and applying it to actually deliver good outcomes for industry. So, it's one thing having a really great model of a battery, but it's no use. You have to actually have all the other tools in place to drive business value for battery companies, for companies, all of those things. And that's where Ionworks comes in. It's really translating that fundamental science into actionable outcomes for businesses. And that is the separation that we really try to follow when we decide with Ionworks if new things we develop should be Ionworks or if they should be PyBAM.
Honestly, I'm impressed and amazed by your answer. Clearly, you really thought this through, and congrats. I think you should probably become an advisor to Sam Altman. So, Sam, if you're listening to this, hey, you should reach out to Valentin here. He has a few advice to give. It really sounds really well thought of, really clean, and it makes total sense as well. And what's interesting is you didn't damage the PyBAM project on itself, but you're also hopefully going to benefit from that. If I understand you correctly, if you're building new models, you can use the newest version that you don't have to develop yourself, correct?
Exactly. Yeah. It wasn't just a purely from the bottom of our hearts decision. We really think this is what's the best for Ionworks, is to the whole modeling community with us. So as people develop new and better battery models, we can then bring them into Ionworks and then deliver them to industry. And it's really a win for both Ionworks and for the academic community developing these models. For Ionworks, obviously, we remain at the state of the art with the models, but for the academic community, it's firstly, PyBAM is there to make it really easy to develop new models. They don't have to worry about the coding and difficult implementation side of things, but also it's a really fast and clear path to impact. If you put your model PyBAM, then it's immediately available for all of the users of the thousands, tens of thousands of users of PyBAM. And so you can very easily make a case for impact that your model is. So we really think that it's a relationship that benefits both the contributors to PyBAM and Ionworks as well.
That's really cool. By the way, you mentioned tens of thousands of users. I'll give you a few seconds to brag, but you should. So tell us, I think I remember the number, how many, I think it's downloads per week or per month are you getting on the model? It is super, super popular, correct?
Yeah, we're getting 10,000 downloads a week on PyBAM.
That was the shortest brag, but that's the best. You don't even need to say more. It's insane. No, congrats. It really is this number is absolutely astounding. It proves that batteries is such an important topic for the world today and for the world tomorrow. Okay, so now I want to ask you something. I want to challenge you a little bit. Don't worry, it's all in good fun. But I want to ask you this. Okay, if I am any serious EV company, I was going to say Tesla, maybe it's not even Tesla, but even if I'm Ford or GM or something, I've been probably working on batteries for a very long time. Maybe I'm using PyBAM, it's open source, it's free. Why would I use Ionworks? And again, it's not really a trick question because I know you are working with some EV manufacturers. Clearly there's something there, but really explain to me why they are not able to build this in-house. What are you helping them do? Why do they need Ionworks?
The building these models is a combination of expertise in lots of different areas, mainly battery domain knowledge, mathematical modeling, and software. And that's really a combination of skills that getting the talent to do all those things is really very difficult. There's a couple of dozen people in the entire world who know how to really build these models very well. And 5 of them works for Ionworks.
Hire everyone else, and so then
yes,
you're the only solution they have.
Yeah, what's our goal is to build the Ben labs of battery modeling, where all of the experts are in one place.
Awesome.
and then empower them to do really incredible things. But anyway, specifically, the challenge with these models and the reason they're not used as much as they could be is the validation and the accuracy of the models and the trust in accurate are these models actually. And there has in the past been, it's really hard to get these models to be actually very accurate. To go on a bit more of a tangent, even inside a battery, it's almost like a biological level of complexity, what's happening inside with all of the chemical reactions, the physics, the transport of lithium. And all you've got to go off is a measurement at the surface of the surface temperature of the voltage and current of the battery. And based on those three measurements, you're trying to infer everything that's happening inside your battery. And that's an incredibly difficult problem.
Yeah.
But we've built now software to solve that problem and to build really accurate and validated models of batteries. And so we can really help companies to shortcut that whole challenge of building accurate and validated models by using our software. In a few weeks, maybe a month, they can get those models up and running. And then they can use those models to do all those things we talked about, designing batteries and finding which design is going to give the best performance for their application.
Did you want to add something? I can let you.
No, that's it.
Okay, that's it. It is interesting. You basically, without Ionworks, what I'm understanding is they're really trying in the dark. They're like guessing what's the model, what is it going to predict? We only have the temperature and the voltage. And with you, they can immediately. So it is such a gain of time. It's just a shortcut for them. I'm sure it is cheaper than hiring a team of 10 people, even though probably you're selling this at a very high price. I'm guessing, I don't know the price actually, but probably is anyway cheaper than hiring a bunch of people. And it's also shorter, is what you said. Is really interesting as well. It's not always about, even if you end up spending a little bit more, but you get your product to market in a month, or at least the battery is working in a month or two instead of 2 years. That has a huge financial impact for companies as well. Okay, that's very straightforward and clear for us to understand. Thank you very much for that. Looking to the future, tell us what's coming next for Ionworks. What are you working on? I'm sure there's a lot of very exciting stuff happening. Take us a little bit behind the curtain, please.
Yeah, the main product we've been developing until today has been really for the experts, the 5 people at the company who are really deep in the weeds. Now what we're doing is we're trying to bring the modeling to everyone at the company who's interested. So not just those 4 or 5 experts, but all of the executives, even the salespeople, the technicians. Everyone should be able to use the models that we're developing together with the experts at the company and instantly get the same levels of insights from those models. What that means today is we're developing much more friendly user interfaces. Anyone can just go to the website and select the model that is accurate for their particular cell, and then run simulations to understand how that cell would behave under different scenarios. So that can help executives make high-level business decisions. You can help salespeople show off the performance of their battery compared to the competitors, and it can help them in their sales process. And it can just making the communication between the real experts within the company and the rest of the team much easier. That's what we're really developing today. And we've just released our new version of that. People can go try it out on our website.
Amazing.
The kind of next step just beyond that is really going back to what I was talking to about AI, is we have a kind of traditional user interface, but with all of the advances in LLMs, we can make it so it can be much more conversational. So instead of typing numbers into a box and clicking run and see what happens, we're developing it where you're just asking questions to the model. What happens if I discharge my battery for 1 hour at 25 degrees? Kinds of questions. And the LLM will know how to run our simulations and bring back the answers in a way that is formatted to show the results that you want. And if it's not, you can iterate with it and get until you get the right answer. And we think that's going to really the barrier to entry even more and make these models much more accessible and really help companies make decisions that are informed by these models much more quickly and much more reliably than they could before.
That's absolutely awesome. I love that. It is, I think I was listening to you, and I think it is a trend with AI, with AI mostly, is I want to say explode the roles in the company, where it used to be the marketing or just doing marketing, but if they need to change a button on the website, they go to the techies, to the developers and ask, hey, can you change? But now there's so many tools. I'm sure you've seen them where like anyone from marketing can just type in maybe into a chat interface or with an easy to use tool and say, hey, can we change that button? And it's so much faster. What's interesting, I was talking before you gave me that answer about the shorter development cycle. Instead of 2 years on a team, it goes back into a few months. And what I hear is the same here. Instead of going to a developer and ask him, hey, can you change that button? Oh yeah, sure. I'll add it to my sprint for next month and blah, blah, blah. It takes a month. You can just do it right now. It will be the same for the sales team. The customer is asking, hey, can I have a battery that's lighter and has the same performance? Types into the chatbot or something. Yes, it's possible. This is how much it costs. You'll have it in 2 months and just sign here to sign the deal. You really are doing this exact theme that we see this movement everywhere in business, but for the battery world. And for that, I'm very excited because I see it as a very big trend. So I'm sure you're on the right path.
Yeah, that's exactly how we see it. Yeah, surfing that wave.
Awesome. Absolutely brilliant. All right. We are nearing the end of our conversation, sadly, already. We both have lives. We have to get back to, I would chat with you for hours, obviously, about batteries. So where can people find you? I'll put the links in the description of the website, but is there somewhere to find you specifically? Where can people follow you and see what's up?
Yes, I'm most active on LinkedIn, posting about and building a company, Y Combinator, open source, all those kinds of things. That's the best place to come and find me.
Perfect. So you're Valentin Sulzer, if I'm correct, Sulzer, something like this?
Yeah, that's right. And there's only one of me. So
Okay, I got it right. Sulzer. Perfect. I really wasn't sure. All right. Thank you so much, Valentin, for being here today and sharing your amazing work with us. It was great, and I hope you'll come back.
Yeah, definitely. Thanks for having me, Gabriel.
Awesome. And
yeah.
Oh, sorry. Go ahead.
But just talk to you soon.
Oh, okay. Yes. I will talk to you soon. And now for the outro. To everyone who's still here listening to us, thank you so much for staying until the end. Don't forget to subscribe, rate us on your favorite podcast platform, and hit that or subscribe button to just see the next episodes. And until next time on the Lobster Talks podcast, see you.